Hello, it's Dr. Bramlett. That's me over here, and I'm a faculty at the University of Illinois. And what I have here are some fetal pearls. This is my standard adult or normal pressure and saturations in the heart, and the objectives that we're going to be touching on in this specific lecture, which is fetal circulation. And the main thing we want to focus on here is this fetal circulation diagram. And I'm just going to kind of orient you to it. The pink numbers represent PaO2. And if you're saying, well, I need to know what saturation is, oh, look at our oxygen dissociation curve. So because fetal hemoglobin shifts it to the left, and I've got 30 here, I come up, I'm in the mid 70s. So wrap your mind around this. Babies in utero see saturations in the mid 70s, right? And so the purple numbers represent the percent of total cardiac output, and the green represents the fetal shunt, so the ductus arteriosus, which, if it remains patent, becomes the patent ductus arteriosus, or PDA. This is the foramen ovale. If it remains patent, it becomes the PFO. And we have the ductus venosus. So let's run through red blood cell down here in the placenta, picking up blood, has a PaO2 of 32, coming up, sort of combines with the portal vein and some other circulatory patterns here, IBC, and then these red arrows here represent flow through the heart. And it is super awesome because this is the most oxygenated portion of the fetus, right? And yet it is directed across the PFO due to the nature of how the PFO is positioned. This is purposeful the way that this is drawn, as well as this eustachian valve, which is kind of like the fluid dynamics director to get it across to the left atrium, left ventricle, out the ascending aorta. So if you look at PaO2 of 32, 28 in the ascending aorta, which goes to the head and neck, which is super awesome that the oxygen finds its way to the head and neck. And if you look at the lowest PaO2, which is in the SVC, which is draining the head and neck, also represents the most oxygen utilization or extraction from the blood. This deoxygenated blood comes down to the RV, which outputs 55%, which means the RV is a predominant ventricle in utero. And then, it's picked up a little bit of oxygen, it's at 19 here, and so it sends a little bit to the lungs, but the lungs are full of fluid and they haven't been expanded yet. And so only 15% goes to the small PAs to the lungs. The majority of it goes across the PDA in a right to left direction down into the descending aorta, where we now have deoxygenated blood coming back to the placenta to pick up oxygen. A couple things happen at birth. These are -1, 3, 5, 7 weeks. And the main thing to know here is that at the moment of birth, the baby takes in a large breath of air, the lungs expand, and we go from a placenta-derived oxygenating system to a pulmonary oxygenating system. And all of these changes occur almost instantaneously. Pulmonary vascular resistance drops. Pulmonary blood flow obviously dramatically increases. Pulmonary arterial mean pressure also comes down. And so in a normal state, it can take 2 to 6 weeks for pulmonary vascular resistance to kind of reach near normal levels. It can take much longer to actual normal, but for all intents and purposes, 2 to 6 weeks. However, if I have persistence of shunts, if I have a VSD, if I have blood flow that is sort of causing the lung to see more blood flow or less, then the way that the pulmonary vascular resistance sort of stretches out can be widely different. This is fetal circulation. Thank you.